Hello everyone, I'm Dr. George Bartuska with the Florida Aviation Network. Welcome to Sky Insights. Today we're going to talk about structural icing on aircraft. Now normally this presentation takes at least a day, but I've got 30 minutes, so we're going to abbreviate some of it, but pay attention because I assure you'll take something away from this. Weather or meteorology is considered one of the most difficult and least understood subjects in the aviation training curriculum. That's why we're here today. Now, total GA operations result in an average of 765 fatalities every year. And this is based on a research project in 2016 with Northern Illinois University. Weather is a contributing factor in 25% of those GA accidents. For more than 100 years of aviation now, fog and sleet, as it was originally called, which is icing, was identified as a weather hazard. Unfortunately, students can miss 100% of the weather questions on the present exam and still pass their exam, but that's changing. The top 10 weather hazards include structural icing, wind, low visibility, obscuration, low ceilings, high density altitude, thunderstorms, turbulence, gusts, and tailwinds. But almost 10% of structural icing accidents end fatally. Research suggests efforts should focus on pilot weather education. Again, that's why I'm here. Despite efforts, weather-related deaths still average about 100 per year. Although wind is the most common weather hazard, only 8% of wind accidents are fatal. Now the byline or the saying from NASA, from the National Weather Service, and from the FAA and AOPA is there's no such thing as a little ice. And that's the byline through this whole presentation. There's no such thing as a little ice. Although we tend to think of icing as a winter phenomenon, icing can occur anywhere, anytime, in any climate, during any season, during any flight. In moist atmospheric conditions like we have here in Florida, especially with air temperature as high as 90 degrees Fahrenheit outside air temperature. There's no such thing as a little ice. During World War II, there were many flight training facilities throughout the state of Florida and Texas, and many of those pilots died in icing accidents because it wasn't totally understood then. Icing encounters can be dangerous. Every icing encounter is unique and unpredictable. Different aircraft may react differently to the same icing condition. Icing-caused accidents usually involve experienced pilots with lots of hours. But remember, there's no such thing as a little ice. Now, in the case of the airlines, this is an operational decision. Their mantra is to minimize the amount of time that aircraft spends on the ground after being de-iced and anti-iced. In the general aviation community, we don't tend to have the availability of de-icing, but some places we do. In the case of a GA operation, however, it's you, the pilot, who have complete responsibility for the go or no-go decision to fly based on your training and the best available information. We have to state the FAR, which is 121.629. No person may take off an aircraft when frost, ice, or snow is adhering to the wings, the control surfaces, the propellers, the engine inlets, or other critical surfaces of the aircraft. The clean air concept is something that was developed by the Boeing Aircraft Company. Airplane takeoff performance is based on clean surfaces. If not aerodynamically clean, the result can be reduced lift, increased drag, increased stall speed, potentially severe roll problems, and possible abnormal pitch characteristics. We've all remember this diagram, the 4 forces of flight from your initial flight training. We have the lift overcoming the weight, and we have the thrust, in this case supplied by the propeller connected to the reciprocating engine to overcome the drag and to create the lift. This illustration is out of the many FAA manuals that simply emphasizes the fact that icing decreases lift, reduces thrust because of icing on the propeller, increases weight, and increases drag. And we're going to look at some of those actual figures next. A small buildup of ice on the wing can reduce lift by 30%. Now that says a small buildup of ice on the wing can reduce lift by 30%, increase stall speed by 15%, increase drag by 200% or more, and as we say, there's no such thing as a little ice. There's mainly 2 kinds of ice that we're going to talk about. The first kind is referred to as clear ice or glaze ice or just ice. Think of ice cubes, or if you're up north where you get icicles hanging off the eave of the house in the winter, that's what glaze or clear ice looks like. Whoops. The other kind of ice is known as rime ice, and it's also called freezer ice. It looks like it has a lot of texture, and it looks just like you would see looking inside your freezer. Now here's something, if you haven't already learned this, that today is going to be the day you walk away with something you didn't know before. We've all been trained that water freezes at 0 degrees Celsius or centigrade or 32 degrees Fahrenheit. And in many cases, that's true. But it turns out there's a phenomenon called supercooled water. Supercooling, also known as undercooling, is the process of lowering the temperature of a liquid or gas below its freezing point without it becoming a solid. In water at the freezing temperature, ice crystals usually form around a dust particle in the water, sometimes referred to as condensation nuclei. Without dust particles, the temperature can get even lower before the water turns to ice. In the laboratory, for example, researchers have shown that it's possible to cool water down to minus 40 degrees Celsius without producing a single ice cube. This supercooled water in a cloud is just waiting for something to freeze on, like your aircraft. And by the way, just for the record, minus 40 degrees Celsius equals minus 40 degrees Fahrenheit. And if you weren't aware of this and you live where it gets freezing temperatures in the winter, just put a bottle of bottled water on your dashboard at night. And when you wake up in the morning, go out in the car and look at that bottle of water, it's probably not frozen, no matter how cold the temperature is. But if you touch the bottle, it will instantaneously freeze solid. Now, ice can form on aircraft leading edge surfaces at altitudes where freezing starts and above. By above, we mean higher altitude and colder temperatures. Water droplets in the air can be supercooled to below freezing temperature, as we just said, without actually turning into ice unless they are disturbed in some manner. These are usually referred to as supercooled droplets. We have supercooled large droplets, SLDs, and we have supercooled small droplets. However, when the aircraft surface disturbs these droplets, they immediately turn into ice on aircraft surfaces if they're not heated, if you don't have an anti-ice or de-ice system. And next time I'm going to talk about icing protection systems. Ice may have a glaze, clear, smooth appearance, or rime rough air. On the diagram in the lower left, we see flying through a cumulus cloud where there may be large droplet supercooled water, that's where we would get clear icing or glaze icing. In a stratus cloud, we might have small droplets and get rime icing. And there's another condition with wet snow, and just in general, we can have both clear icing and rime icing. Now here's some illustrations of those. The upper left is clear ice. And you have to look careful at this. We're looking at the stagnation point of the leading edge of that wing in the middle. And if we had a side view, you would see that we have what looks like two horns sticking out from the leading edge of the wind, one up and one downward. The one on the right is rime ice, the freezer ice, and it just kind of opaquely covers the leading edge of the wing. Then on the bottom left, we have a combination of both. We have clear ice, we have rime ice. Once again, there's no such thing as a little ice. Icing normally requires two conditions: visible moisture, such as are in clouds, fog, precipitation, and low temperatures capable of changing moisture to ice, about plus 2 degrees centigrade to minus 20 degrees centigrade, or plus 36 F to 4 degrees Fahrenheit. Remember, when the air starts to go over the wing, it speeds up and it gets colder than it was before it encountered the wing. Icing conditions normally don't exist outside of the clouds, if there's no freezing precipitation, and if the temperature outside is above the freezing range. This is a picture from the National Weather Service's Comet Weather Training Program. And let's look at this carefully. We see way above it says ice cloud, no icing threat. That's where the airlines are flying, above all this for the most part of their en route flying. And we see below, where they're below freezing, where we're above freezing temperatures, there's no problem. But above 0 degrees Celsius and up to minus 40 degrees, where we can still have supercooled liquid in the cloud, that's where the icing threat exists. Thus, the icing threat is a major threat to GA operations and commuter aircraft. Business jets will generally be flying up at least as high, if not higher, than the airlines. Now, freezing rain is a whole other situation. It is the most dangerous thing you can encounter in this subject matter. You need to avoid it. If it starts happening on your windscreen, you need to immediately call air traffic control and get to a lower altitude, reverse course, and get on the ground as soon as you can. And you might say, well, how can this happen? One of the classic ways it happens is during a warm front in the winter. Remember, everything's relative. Precipitation begins to snow as higher altitude. In fact, just about every drop of water that's ever hit you in your life started out as a snowflake or an ice crystal, and on the way down it melted. Well, here it's falling, and as it falls through the frontal boundary of the warm front, the snow melts as it falls through the warmer air, turning it to rain. But then it hits the colder air that's of that cold air mass, and as it enters a layer below freezing, it becomes supercooled. And if your aircraft is there and your aircraft is nice and cold, it's there to freeze on impact with any object they encounter, whether it's a C-130 or a Cessna 182. So clear the prop, good flying. And what I want to do now, if you are watching this at a later time, there's going to be a quiz at the end, and I want to review those questions that are on the quiz. Weather is a contributing factor in 25% of all GA accidents. Student pilots can miss 100% of the questions on their exam, their written exam, and still pass. That's the way it is now, but it's going to change. Despite efforts, weather-related deaths still average about 100 a year. One of the conditions necessary for structural icing is visible moisture. And like we said, if you stay out of the clouds, you're probably going to stay out of icing. The atmospheric environment most likely to have the highest structural icing accumulation rate is freezing rain. The dew point temperature is the temperature at which the air must be cooled to become saturated or 100% humidity, relative humidity. The amount of water vapor or atmospheric moisture that air can hold depends primarily on the ambient temperature. Supercooled waters can stay liquid down to minus 40 degrees Celsius or minus 40 degrees Fahrenheit. As a partial of air rises, it cools because of the decreasing atmospheric pressure. Although we think of icing as a winter phenomena, icing can happen anytime, anywhere. Ice formation on aircraft is usually worse when flying through clouds. Icing typically occurs where there's supercooled water present, whether they're large drops or small drops. Aircraft icing will degrade an aircraft's wings lift, generation, the engine's propeller thrust output, and the aircraft's weight and balance. The clean airplane concept, championed by Boeing Aircraft Company, improves takeoff performance by increasing wing lift, reducing aerodynamic drag, and decreasing stall speed. There's two main kinds of structural icing, clear ice and rime ice. And as we said, there's no such thing as a little ice. So thank you for joining us. I'm Dr. George Bartuska with the Florida Aviation Network. Join us next time for our next weather topic, which will be Icing Protection Systems. Now stand by for the code to get your wings credit.